Let's take a look at some examples of the process called factoring by grouping. If we have a polynomial with 4 terms, we can sometimes, not always, but we can sometimes factor by grouping, which means I would take 2 of the terms together and look for their greatest common factor, and then do the same thing for the other 2. So let's look at an example and see what happens. If I look at this first example, the first 2 terms, x cubed plus 4x squared, they have x squared as a common factor. So I could write this as x squared, and then in parentheses x cubed leaves an x behind, and 4x squared would leave a 4 behind. And now to write an equivalent expression, I'm going to put a plus sign next, and look at what comes afterwards. So I have 7x plus 28. So between those 2 terms, just between those 2 terms, the common factor is 7. Interestingly enough, and this is kind of important, what it leaves behind, if I factor out a 7, 7x leaves behind an x, and 28 leaves behind a 4, because 7 times 4 is 28. So what's kind of special about this is that x plus 4 is a common factor of both what happens in front of the plus sign, the big kind of central plus sign, and what happens after that plus sign. So x plus 4 is a common factor, and I can factor that out. It leaves behind an x squared, x plus 4 times x squared, and a plus 7. And so the x squared and the plus 7 becomes our second factor. So this is a factored expression that's equivalent to what we started with. There were no common factors of all 4 terms, but we could find common factors of the first 2 and of the second 2 that left behind exactly the same expression. So if that didn't happen, if we didn't have exactly x plus 4 in both of those places, then we wouldn't have been able to continue. We can always check our work by multiplying out. And so if we do that, we can double check. X times x squared is x cubed. X times 7 is 7x. 4 times x squared is 4x squared, and 4 times 7 is 28. And so the order is slightly different, but we get the same 4 terms. And so we can see that the factored expression is the same as the original expression. So looking at a couple other examples that show slightly different twists, some slightly different things. So example 2 here, if I look at the first 2 terms, think about, and I would encourage maybe to pause the video for a moment and think about the common factors of the first 2 terms and the second 2 terms. So the first 2 terms have a common number factor of 5 and also x squared, and what's left behind is x plus 8, since 5 times 8 is 40. Now looking at the second 2 terms, this is kind of a trick question. There is no common factor between x and 8. But what I can do, I can think of that plus x plus 8, I can think of that, it turns out, that notice, that is the same as this first, what's left behind from the first 2 terms. So I can think of that as 1 times x plus 8. So x plus 8 is the common factor. And then the other factor would be 5x squared plus 1. Right, so I need that placeholder of a 1 so that multiplying it back out, we get the last 2 terms. So that would be the factored expression. The third example that I want to take a look at introduces some issues that can come up with minus signs. So again, we can look at the first 2 terms. The common factor there would be 4x squared, since 4 divides both 4 and minus 20. And then what's left behind is x minus 5. 6 is a factor of both of the second, of the last two terms, but now there's a little bit of an issue. So I can factor out a 6, and it's going to leave behind an x and a 5. But what we started with, we have a minus here. So in our other examples we had plus signs, in between the first two terms and the second two terms. Now if I have a minus, I need to think about, do I want to put a minus sign in front of the 6 or a plus sign? Well, I kind of need to put a minus sign there, or else put a minus sign in front of the x, but that would be kind of awkward. What kind of guides our ultimate situation is that I'd really like this to be x minus 5. So I kind of need this to be x minus 5. Well, it works out that if I put a minus sign inside, I can also put a minus sign outside. Because, this is a plus sign, but what happens when I add the parentheses? This means negative 6 times negative 5. Negative 6 times x and negative 6 times negative 5. And multiplying those negatives is going to give me exactly the positive 30 that we started with. So essentially what we're doing is we're factoring a negative 6 from both of those terms. So factoring out negative 6 from the x gives me just negative 6 times x. Factoring out negative 6 from a positive 30 leaves behind a negative 5. And so we end up with 4x squared minus 6 times x minus 5. So this is our final factored expression. The order is a little bit different than the other examples. I took the common factor and put it at the end instead of the beginning. But the order of multiplication doesn't really matter. We can switch, we can reverse the order of multiplication and we still get the same result. So that would be an okay way to write the final answer. Well, I encourage you to pause the video for a moment and work on the following question. Try to factor by grouping the following expression: x cubed plus 7x squared minus 5x minus 35. In just a moment I'll work through the problem, but I encourage you to pause the video for a moment, try to work it out on your own first, and then check your work by watching the end. Alright, well, let's take a look at the answer. I hope you paused the video and tried this out. The first two terms have a common factor of x cubed, and x plus 7 is left behind. The second two terms, I have a minus sign issue here, so I'm going to put a minus 5. 5 is the common number factor. And similar to what happened in the last example, when we factored out a negative 6, it turned that plus sign to a minus. Now, if I factor out a negative 5, it's going to turn this minus sign to a plus. So we end up with x plus 7, which is a good thing because that's what we had in the first set of parentheses. So the final answer then is going to be x plus 7 times x squared minus 5. I hope you enjoyed the video. Thanks for watching.